Alright, hi everybody. We're going to do some heat transfer problems today. My name's Damon and I am an engineer in training in Canada. Graduated from the university 2 years ago. I have my iron ring and I've gone through 6 years of engineering education, and I'd like to share some of my knowledge with you guys today. And what we'll be doing is some heat transfer problems. So let's take a look at a question here. So this is a starter problem in the conduction topic. So let's get the problem statement here. All right, so this is question 1.9a. So a glass window of width W is 1 meter and height H is 2 meters, is 5 millimeters thick, and has a thermal conductivity of K equals 1.4 watts per meter Kelvin. If the inner and outer surface temperatures of the glass are 15 degrees C and minus 20 degrees C respectively on a cold winter day, what is the rate of heat loss through the glass? So let's write out the problem. So this is what it looks like, kind of 3D here. So this is the glass. All right, so problem tells us width, height, and thickness. This would be the width, height, thickness. We know that width is 1 meter, height is 2 meters, thickness is 5 millimeters, which is this many meters, 0.005 meters. All right, and we know property of the glass, K glass, which is 1.4 watts per meter Kelvin. Okay, it also tells us the temperature at either surface of the glass. So we've got the inner and outer surface temperatures. So let's call this TH for T hot and TL for T low. So T hot is 15 degrees C, which we'll convert to Kelvin for these problems. So 288 Kelvin, you just add 273 to the degrees Celsius. And then T low is minus 20 degrees Celsius, so that would be 253 Kelvin. All right, so we're looking for the rate of heat loss through the glass. So that would be variable Q, Qx. So let's redraw this in a different coordinate system. So this will be our x-axis. We're going to assume that temperature, or the heat, is flowing from hot to cold. So this direction, from T hot to T low across the x-axis. This is our thickness of the glass. And so now we have to use the conduction equation. So the conduction equation is that heat transfer is negative K dt dx. So what we do with this is, to get the heat transfer that we're looking for, we multiply both sides by area. So we just get Q equals Q double dash X times A, or minus Ka dt dx. So to simplify the problem, we can make some assumptions. So let's make a list here. Assumptions. The first assumption is that this is a one-dimensional problem. We're just going to deal with the x-axis. Second assumption is it's steady state, so there's no flux. The K, the property, the thermal conductivity of the glass is constant, and the heat transfer is also constant. That will help simplify this problem. So back to our equation here, we can simplify this. So Qx equals minus Ka, so dt, so that's just change in t over change in x. Let's call this x initial, and let's call this x final. So this just reduces to minus Ka T low minus T high, right? That's just the change, our final one minus our initial one. And same thing for x final minus x initial. So in this case, x final minus x initial is just t, and we know that t, it's given the problem, so that's simple. Minus Ka TL minus TH over T. We can simplify this a little bit, take the negative sign out, and we're just left with Ka TH minus TL over T. So at this point, we've got pretty much everything we need. When it talks about A, this is the cross-sectional area that Q is going through. So that would be this face right here. So that would be, we can break that down further. A becomes the product of width times height, and then the rest of our equation is still the same. All right, so now we can throw in our numbers. This is actually pretty easy. We've got everything given to us. 1.4 watts per meter Kelvin. Width is 1 meter. Height is 2 meters. TH, our higher temperature, 288 Kelvin, minus our lower temperature of 253 Kelvin. Divide that by the thickness, 0.005 meters. So our heat transfer should be in watts. So let's make sure all the units work out. So meters cancels with meters, meters cancels with meters. Kelvin, this reduces just to Kelvin. And then Kelvin cancels with Kelvin. So we're left with 1.4 times 1 times 2 times 288 minus 253 divided by 0.005, and this is all in watts. So we'll throw that into the calculator. So we got 1.4, 1, 2, 288 minus 253 divided by 0.005. Okay, so we're left with 19,600 watts. So Q. Or you could say 19.6 kilowatts. So the final answer here is that the heat transfer through the glass is 19.6 kilowatts. And what's important to remember is that, so this is a positive number, which means our assumption of the direction that Q is traveling is correct. It's going in direction with our x-axis, hence the positive value here. So that's the end of this problem, and that's just a introduction conduction problem. So thanks for watching.